Okay, let me start this presentation off just by letting people know that if you haven't decided on a niche of the industry that you'd like to get into after graduation, you should check out computer security. It's becoming very big. I mean, every corporation needs to protect their data from malicious programmers getting it and selling it or doing whatever they do with it. It can be very lucrative. There's big pay in the security specialist field, so that's a big motivation. A lot of these specialists can work from home because basically you just need an internet connection and you can do penetration tests from your house if that's allowed by your company. So we decided to choose the operating system Backtrack 5, which is specifically built for security specialists and penetration testers in the industry. It's a Linux distribution, so it uses the Linux kernel and everything that comes along with it. It boasts over 300 tools that continue to keep updated for the user by the operating system. So the operating system does it automatically for you. You don't have to keep going out there getting the latest version of the software and downloading it. It does it automatically, so it keeps you up to date with the latest, you know, anything that's going on within the industry. Okay, so the purpose of this operating system, obviously, as I discussed, it's made for security specialists in the industry. So the purpose of the operating system is for network penetration, security audits, and just cracking passwords, whatever that they need to do. There's all types of tools on there. As I mentioned, over 300 tools. So I mean, you can take your pick on the tools. First, I'm going to be talking about the architecture of the Linux kernel that's used by the operating system in the beginning of this presentation, and then I'm going to get into the actual user apps that make this operating system a specialty Linux distribution. So you'll get to see some of the cool features of that. Okay, so now let's get into the kernel architecture. We had the kernel 2.6.38, and that kernel is monolithic kernel, although it does allow for module loading for extensibility such as device drivers and whatnot. Some of the kernel components are virtual memory, file system, networking, memory management, threading capabilities, etc., etc. So now let's get into a cool feature that I wanted to mention about the virtual file system. It's called RCU, Recopy Update. It's a mutual exclusion method where threads that are trying to access data but not actually modify the data, they can access that shared data without acquiring a conventional lock on that data, on the critical section. Whereas the threads that update the data have to use a special callback scheme to update the data. They update all the global references to the updated data with the new copy and use the callback scheme to free the old copy after all the CPUs have lost local reference to it by going through a quasient state, basically like a context switch, a grace period in time, so that it knows all the previous readers are done using that copy of the data. Now the disadvantage of the right side updates is that the old data structures must be left in place while all pre-existing readers are done with until they're done with the data. So it can be expensive when they keep making copies of that data. So on that side it's a little expensive, but on the read side there's very, very minimal overhead when it comes to reading the data with multiple users. Because of the expensive overhead on the right side, the recopy update mechanism is definitely more suited for scenarios where the data is to be protected is read more often than written and updated to, so just keep that in mind. For uniprocessor systems, the recopy update mechanism actually eliminates the need to mask interrupts for mutual exclusion. Therefore, the recopy update mechanism is suitable for mutual exclusion in network routing tables, device state tables, deferred deletion of data structures, and multipath input-output device maintenance. Okay, so on top of the kernel are some system libraries that basically do things like mediate the exchange between kernel operations and user space operations, and it can change the execution mode from kernel mode to user mode if a system call is made. Then there's utility code. It's used for helping manage different tasks on an operating system, including but not limited to tasks like accepting logins, updating log records, responding to network connections, requesting terminals, etc. Next, after that, comes the user space, which is the top layer of the system. User space is where all the applications that are used on a daily basis are and cannot have direct access to the kernel. If the user application needs a system function, it must make a system call to mediate between the user app and the kernel. Okay, so now that I've given you a little bit of background on the architecture of the kernel, let's now get into the user applications that make this operating a special distribution of the Linux kernel operating system. Security tools in the operating system have many different categories because there's so many of them. So some of the major categories I'm going to mention are information gathering, vulnerability assessment, exploitation tools, password tools, privilege escalation, reverse engineering, etc. There's many other categories that you can look up on your own. Okay, the first major category that we're going to be talking about as far as security tools go is information gathering. The first tool I wanted to mention was SSLC Audit. It's a tool for testing the secure sockets layer of clients for man-in-the-middle attacks. A man-in-the-middle attack is basically when a malicious programmer, it creates two connections between two end users who want to communicate over the wire, and they may think that they're communicating with each other without any interruption in between. But the attacker is actually talking to one end user, receiving his message. He can get any information in that message, extract it, and then send it on to the other user without them ever knowing what went on. So that can be very bad, and you can leak data out that way. So you definitely want to be secure and not have any man-in-the-middle attacks. It can also test for what server certificates the client trusts enough to establish a secure sockets layer connection. So that comes in handy. And it can also test for the flavor of the secure sockets layer protocol the client supports. Example, TCP, UDP, DHCP, etc. Okay, so here's a picture of a man-in-the-middle attack that I just wanted to show to represent so everybody kind of got a clear idea of what's going on. On one end you see the victim, on the other end you see a web server, and you see that the green line is supposed to be the original connection, and then there's an attacker in the middle. He makes a connection with the victim, makes a connection with the web server, and then all information flows through the attacker. So he can basically just extract any information he'd like to and send the original message onto the web server like nothing ever happened, nobody ever knows. He gets away free and clean and can do some big damage. So you definitely want to avoid that. Okay, so the next category that I'd like to talk about is vulnerability assessment. Now this tool is called Linus. This tool scans the system and software for security issues. It runs a system scan of files such as the bootload of files, configuration files, software packages, logging and auditing files for vulnerability. It runs the reports on system and file forensics, and it can test for secure sockets layer certificates, outdated software, incorrect file permissions, and firewall auditing. Okay, so the next tool in the vulnerability assessment category is .pwn. It's a directory traversal tool. It detects directory traversal vulnerabilities on remote HTTP FTP server systems. .pawn checks for the presence of boot.ini on vulnerable systems through directory traversal vulnerabilities, so it is assumed that the tested systems are Windows-based HTTP FTP servers. Currently, the traversal database holds 871 attacks. So that's a lot of attacks that the database can check against to make sure that the system is clear of vulnerabilities. So it's definitely a good tool to have in your toolbox. Okay, so the next major category I'd like to talk about is exploitation. The first exploitation tool is HTExploit. HTExploit is an open source tool written in Python that exploits a weakness in the way that HT access files can be configured to protect a web directory with an authentication process. By using this tool, anyone can be able to list the contents of a directory protected in this way, bypassing the authentication process. Some of the features of HTExploit are: the first one, multiple modules to execute. Second, save the output to any specific directory, so if you gain access to the htaccess file, you can just save any content you find that you'd like to keep. You can save it to a directory. As HTML reporting, uses multiples, word lists to probe against htaccess bypassing. Mode verbose for full detailed information. recursive crawling engine. Okay, so the next security tools category is passwords. The first tool we have is Rainbow Crack. Rainbow Crack for GPU is a hash cracking program in which Rainbow Crack utilities take advantage of both the effective time memory trade-off algorithm and powerful computing capability of NVIDIA GPUs. With two technologies combined, Rainbow Crack for GPU is significantly faster than any non-GPU accelerated rainbow table lookup program and any straight GPU brute force cracking. In this Rainbow Crack project, they focus on the development of optimized time memory trade-off implementation and generation of large rainbow tables. Okay, so in the previous slide I mentioned the tool Rainbow Crack, which took advantage of the processing speeds of GPUs. So I just wanted to mention an interesting fact that I read in a Yahoo article last week was the Titan supercomputer became operational back on October 29, 2012, and it became the fastest supercomputer in the world last week. I mean, just look at its architecture. First, it's got 18,688 16-core CPUs, 18,688 GPUs, and I mean the power consumption 9 megawatts. That's ridiculous. Memory 710 terabytes. Speed 20 petaflops. I've never even heard of petaflops, so it's got to be really fast. Cost 97 million, and its legacy is the first GPU-based supercomputer to perform over 10 petaflops. So, yeah, petaflops has got to be really fast. So here's just a picture of the Titan supercomputer I wanted to show. It's maintained by the Oak Ridge National Laboratory in Oak Ridge, Tennessee. So, yeah, I just wanted to show you a cool picture of that. Looks pretty cool. Okay, so also part of the password category is a tool called AirCrack NG. It's a network software suite that has packet sniffers, WEP and WPA, cracker, and analysis tools for those certain types of networks. The program can run on both Linux and Windows-based systems. Some of the features of the suite are AirTune, which is a virtual tunnel interface creator. AirServe allows you to access the wireless card from other computers. AirPlay, it's a packet injector. AeroDump, packet sniffer places an air traffic into packet capture files and shows information about networks. Okay, so that concludes our presentation. Here's just a couple of references.